Greetings folks and welcome back to another CCNA archive. In this one, we're going to have a look at numbers, specifically binary and decimal, and how you can convert between the two quite simply just using what's called a 128 table. Hope you enjoy. I want you to imagine decimal first of all. So in decimal, we always read left to right. So you'd have the column of 0, okay? You'd have the column of tens, you'd have the columns of 100s, you'd have the columns of 1000s, okay? And as you go along, I've put 100, 1000s. As you go along, yeah, if I wrote down the number 5, 3, 4, 2, you'd be able to know that that is the number 2435, okay? And we can make any kind of combinations with this. The same rule applies as far as binary is concerned, except we use some slightly different numbers. Our first column has the value of 1, okay? I mean, this one is value of 1 as well, really. Okay, so it's got the value of 1. Then moving up, we just double that. So the next value becomes 2. Moving up, the next value becomes 4, then 8, then 16, then 32, then 64, then 128. Now, what you'll notice here is that I've created 8 places. Yeah, 8 columns. 1, 2, 3, 4, 5, 6, 7, 8 columns have been created. Now, if I were to throw binary underneath this, so let's say we put 1, 1, 0, 0, 0, 0, 0, 1. Okay, all I need to do is add the columns that the value of 1 is underneath. So in this instance, it would be 128 because this column has a 1 in it. Okay, plus the value of 64. So let's add that to our mix. So do it here, plus 64. And then the only other one with a value underneath it is the 1. So we'll add plus 1. And then we get the value of 193. And the value can be the same anyway. So if I even go 0, 0, 0, 0, 0, 1, 1, I just need to add these two columns. So 2 plus 1 equals 3. Okay, I could also go full out on this one. 1, 2, oh, sorry, 1, 1, 2, 8 ones all in all. So this is going to be the value of 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And I press enter. And there is my maximum value because all these binary bits have been turned on, and when I turn them all on, the biggest number I can create with 8 binary bits is 255. What's the smallest number I can create? Well, you've probably guessed it. If everything's turned off, you add nothing together, you get a total value of 0. So that's how we can go through the binary system. And basically, if we go through any combination of ones and zeros of all these bits, we can create every single number between 0 and 255 using only these binary bits. So I'll just start this method off. So this one would be 1, where we have the first number engaged. Then we'd go into 2, where we have the value of 2 is engaged there. So that would just equals 2 because that's the only value there. Then we want to create the number of 3, so we have to turn 1, 2 and 1 together. So we'd use 3 there. If we wanted 4, it would be 1, 0, 0. That would create 4. If we wanted 5, it'd be 4 plus 1. That equals 5. If we want 6, it'd be 4 plus 2, which is 6. Very, very simple maths, and we can keep climbing and climbing and climbing. So here we go, 1, 1, 1, that is going to equal 7 because that is 4 plus 2 plus 1. And then we get into the next field, so it's going to be 1, 0, 0, 0 equals 8. Yeah, and the number system just keeps going up and up and up. And you'll start to see a pattern. If you actually start writing this out, you'll actually start to notice that this column, as we've been counting up, alternates every time. Yeah, it just goes 0, 1, 0, 1, 0, 1, 0, 1. Then you'll find that this column alternates every 2 places. So it'll go 0, 0, 1, 1, 0, 0, 1, 1. Then you'll find this column alternates every 4 places. 1, 1, 1, 1, or 0, 0, 0, 0, 0. Yeah, this one is going to alternate every 8 places, every 16 places, every 32 places, every 64 places, and every 128 places. You'll get like 128 zeros followed by 128 ones. That's how we would end up counting up. If you were to write out binary just like that, you will see a pattern emerge, and that's one of the beautiful things about it. One of the downsides with binary is that it takes up a lot of space to signify a very, very simple number. So even just to say the number 8 there, which in decimal we can do with a single character, we've had to use 4 binary bits And that is one of the downsides. If you ever want to convert decimal into binary, it's a slightly different process. I mean, you can still use the same concept. So let's say we get given the binary of 1110000, and we wanted to convert that into decimal. So as I say, we just put our 128 table above it. 128, 64, 32, 16, 8, 4, 2, 1, and then we just add those values up. Brilliant. Okay, so this one's going to be 128 plus 64 plus 32, so that's going to be 160, and then 224, 224, yep, fantastic. So what if though you get a value where they'll say, okay, you want to convert the number 239 into binary, okay? That becomes a little trickier. You can do it using the decimal conversion. So you can literally write out your 128 table as we did just a moment ago. And what you want to do is ask yourself the question, does 239, or does 128 fit into 239? The answer is yes to that, yeah? So there we go. So then what I want to do is I want to say, well, what is 239 minus the 218 that I've just taken from it, okay? So I'm going to say that is A21, sum of A21 minus 128. Okay, so now when I subtract 128 from 239, I'm left with 1111, and I ask the same question, does 64 fit into this 111? Yes, it does. Fantastic. So I'll turn that into 1. So now I'm going to take 64 away from 111, so that's going to equal A22. Sorry, no, I'm going the wrong one. B21 minus 64, and now we've got 47. Does 32 fit into 47? Yes, it does. And then we do the same math, so we'll say 47 minus 32. That equals 15. Does 16 fit into 15? No, it does not. Okay, so that's going to be a 0. So we don't have to subtract anything here. The value is still 15 moving across. 15, does 8 fit into 15? Yes, it does. So we'll turn that on. And now we can say 15 minus 8. Oh, I just want to do it right. Equals 15 minus 8. I did do that one right that time. But it's formatting in the date. So let's just put some equals the sum. Oh my word, that's being a pain. Right, so either way, it's 7. So does 4 fit into 7? Yes, it does. And then we'll take that away, so we'll end up with 3. Does 2 fit into that? Yes, it does. 3 minus 2 equals 1, and there we go. And then we should have our value here. So basically 239 is all of this subtracting. We figured out the binary of that just by doing this nice kind of gradual subtraction. There is another way in which you can do it. So let's take the value of 240, for example. What you can do is you can just divide it by 2, okay? And by dividing by 2, so when you decide to divide the value by 2, you'll get a whole number plus a remainder. So we're not using fractions. We don't believe in halves here or quarters or anything like that. We just want whole numbers. So in this instance, 240 divided by 2 is 120 with a remainder of 0. So then I'm going to take 120 and I'm going to divide that by 2. So 120 divided by 2 is 60 with a remainder of 0. 60 divided by 2 is going to be 30 with a remainder of 0. 30 divided by 2 is 15 with a remainder of 0. 15 divided by 2 is technically 7 with a remainder of 1. Okay, because you can 7 and 7 equals 14. Plus 1 equals 15, so that's our remainder of 1 there. Okay, so 1 remaining, no fractions. So now we have 7. We want to divide that by 2. Now that is going to be 3 with a remainder of 1. Again, 3 plus 3 is 6, plus 1. That's our remainder there. And then we have 3 divided by 2 is going to be 1 with a remainder of 1. And then finally, 1 divided by 2 is going to be 0 with a remainder of 1, sorry. okay? Because you can't divide 1 by 2 without going into fractions, and we don't like fractions. And what we have now is we have our binary value, and we just need to read it up, okay? So we start at this number here and we go all the way up, and that will give us our binary value. So if I plumb this in here, we've got 1, 1, 1, 1. So there's my 4 ones, followed by 4 zeros, 0, 0, 0, 0. And let's just quickly add that together. So we're going to say equals 128 plus, going for a double equals somehow, 128 plus 64 plus 32 plus 16. Nothing else is being added, and yeah, there's our value. So just being able to divide and then read up the way works really, really nicely there. Well, that's the end of this video, folks. I really hope you enjoyed that one. Do all the usual things, like, subscribe, hit me up with any comments if you want any of those topics explained a little further in detail. I'm always happy to help out. Other than that, I'll see you next time.